In today's video, here is a nice problem is coming from Polish Mathematics Olympiad edition 1993. Here is the following application. We have f from r to r. Here is the following statement. We have this function f of x plus y minus f of x minus y equals f of x is multiplied by f of y. So our goal, we are going to determine all the functions which verify in this statement. Okay, you guys, you can give the hands to us from prayer into solution. Go ahead, pause this video when you want to come back to see a full solution. Okay, by the way, don't forget to hit the subscribe button and support the channel. So let's jump into this one. So always, in order to deal with this function and reduce this expression to the smallest expression possible, so we are going to check the obvious cases. By taking the smallest values of x and y, it will reduce this expression. Okay, let's take y equals x equals 0. Okay, let's set x equals y equals 0. So I'm going to take this value and insert them into each variable here. So I get the following. I get f of 0 minus f of 0, which equals f of 0 square, which equals 0, because you have the difference of f0 minus f of 0. Okay, so this ultimately f of 0 is 0. Okay, so we have determined the first obvious output of this function f of 0 equals 0. Let's move on ahead to see what's the next expression. Also, I'm going to set x equals y, so to see what's the next expression. So we get f of 2x here. This one I get minus f of 0 because x equals y. This one is giving me f of x square, like this. Okay, so this one is already 0 because as we determined above this expression f of 0 equals 0. So I will end with this expression. I get f of 2x, which equals f of x square. Okay, so let's see these two facts for later. So we have first fact, the second fact. Let's move on to determine the third equation. Also, let's set x equals minus y. Okay, if I'm going to do that, the first one is given as 0 because x equals minus y here. So I get f of 0 minus f of, this one is given as x minus x, which is 2x. So get 2x here, which equals f of x. The other one is given as minus f of, is multiplied by f of minus x, like this. So this one is already 0. Okay, I have determined f of 2x by moving over this minus to the right. By moving this minus sign to the right side of this equation, you get minus f of x multiplied by f of minus x. At the same time, if you take a look at the above expression, we get f of 2x equals f of x square. So let's replace that by that factor right there, which is f of x square. Okay, I'm going to move over this product to the right side. So I get the following. I get f of x square plus f of x is multiplied by f of minus x, like this, which equals 0. Okay, since we get f of x squared and also I get f of x here, I'm going to take one of the f of x as a common factor. So I get the following. I get f of x factor f of x plus f of x f of minus x, the whole thing equals 0. So I have ended with this nice expression. So this one is telling us I have two things here. I have f of x equals 0 or f of x equals minus f of minus x, because if we have f of x equals 0 is given as f of x equals 0. The second one, if we have f of x different than 0, if f of x different than 0 is given as f of x plus f of minus x equals 0. By taking this one to the right side of this equation, I get f of x minus f of x. This one is telling us f is an odd. Okay? For f of x equals 0, I'm going to stop here. But for the second case, when we have f of x different than 0, which means there is a function ahead, we are going to determine it. Okay? So this is what happened. The function that we are going to look for it is an odd function. Okay, so we are going to work on this case. This is one side. Let's check the other side. The next trick that I'm going to use here, let's set x equals 0 and y equals minus x. Let's set x equals 0 but y equals minus x. So I will have the following. This one becomes f of 0, this one becomes minus x, f of minus x minus f of x will be 0 minus y will becomes minus x, which is x, which equals f of 0 because I have replaced x with 0, but this one becomes f of minus x, like this. Okay, here is the thing. So this one equals 0 because this one equals 0 is multiplied by f of minus x is given as 0. Okay, so since the right hand side of this equation equals 0, which means the left hand side of this equation must be equal 0 as well. Okay, so let's take one of the function to the right. I will be ended with the following: f of minus x equals f of x. So I have ended with this nice expression. This one is telling us the function f is an even, which it's clearly impossible. As we're working on this function, we found it was odd. Continue working on this one, and we found the same function is an even, which is clearly impossible. Okay. Now we found the three things here. We found the same function which equals f of x equals minus f of minus x, and also we found f of x equals f of minus x. Let's combine these two equations together to see what's given us. So I got the following. I have f of x which equals minus f of minus x at the same time equals f of minus x. Okay, so let's take this one to the right. I get the following. I get 2 times f of minus x. Now I'm going to work on this one. So we have minus f of minus x equals f of minus x. Let's take this one to the right and solve the equation. So we get the following. You get f of minus x plus f of minus x, which equals 0. Equivalent 2 times f of minus x equals 0. In the other word, f of minus x equals 0. Okay. Now we found two things. As we work on this function, we found f of x equals 0. At the same time, we found f of minus x equals 0. Okay. So by combining this together, so I get here f of x equals 0. At the same time, we found f of minus x equals 0. Okay. It's clearly we have proven f of x must be equals to 0. Okay. For all x as a real number. So we have proven this function must be equal to 0. F of x equals 0 for all x as a real number. Okay. So I have done with this problem. By the way, don't forget to hit the subscribe button and support the channel. Thank you for watching. I will see you next video. Bye.